squads? Today we're going to learn about angle and radian measurement. So we're kind of in the trig. So angle and radian measurements. Let's talk about, start getting the unit circle ready. So if we have this angle, a couple definitions. We always start on the x-axis, and this is called your initial side. This part here. And then as we continually travel this way, counterclockwise, we end up creating this angle. This angle is called your terminal side. Terminal side is where the angle terminates to create this angle. So our goal is to create this. We want to use our axis to be able to help each other figure out what quadrant we're in. So when we talk about quadrants, we're going to say this top right sides are quadrant 1. We go counterclockwise, quadrant 2, quadrant 3, and then quadrant 4. So we have 1, 2, 3, 4. Our angle's going this way as well. Everything's going counterclockwise, and try to use our x and y axis to help us create which side is going to be on. Alright, so another important concept is coterminal. So coterminal. So co means what? Co means sharing. Terminal means that terminating side. So where are we sharing that terminating side? How we do that is, let's say we have the same angle, and this is our angle there. Our coterminal would be going around one full revolution and then going back to that same exact spot. We're meeting at the same exact spot. So the example I always use is, let's say we're running on a racetrack, right? And if you run from the start, which is at 0, you run one full lap, what happens? We get back to 0. Well, we're not at 0 degrees. Let's just say that's 360 degrees. So 0 and 360 degrees is actually coterminal angles because you're ending at the same spot. So we can continually just run around that track over and over and over, and then 720 degrees is also coterminal. So 0, 360, 720, those are all coterminals. Alright, so our goal is to wrap around one full revolution. So what math can we do in order to get that? Well, we can technically take wherever we're at, whatever angle we're at, and add 360 to it, or take the angle we're at and subtract 360 from it. If we do that, where 360 means we're just adding it, so we're continually stopping at the same spot. Right, so that's coterminal. Coterminal will be very important when we actually talk about unit circles. So let's take a couple examples for that. So if I have let's say we have 135 degrees. So your first question should be, which quadrant is that in? It's in quadrant 2. Why? Because it's in between 90 and 180. So it's right there, right in the middle, in between 90 and 180. So it's in quadrant 2. That's your first question. Your second question is, what is a positive coterminal and a negative coterminal? So all we have to do is start here, go all the way around and hit there. So you can start at 135 and then add 360 degrees. Or we could go to 135 and then subtract 360. So these guys right here will give you the coterminal at 135 degrees. We're essentially adding and subtracting 360 from it. When we talk about radians, because the title is radians, we talk about the circumference. So circumference over circle is 2 pi r. Let's say our radius is 1, so then our circumference is 2 pi. So one full revolution is going to be 2 pi measurement, all right, which is also equivalent to 360 degrees. So when we cut that in half, 180 is equivalent to pi, because half of 2 pi is pi. And then half of pi, which is 90 degrees, is going to be pi over 2. And then 270 degrees is going to be, if it's 1 pi over 2, 2 pi over 2, this guy has to be 3 pi over 2. All right, there is a formula to convert, so let's convert that. To convert from radians to degrees, so radians to degrees, you have to just multiply by 180 over pi. And to multiply from degrees to radians, you just times it by pi over 180. It's a rule of thumb, but not always true, but radians will usually have the pi. Not always. They might say it's 1 radian, so it's still a radian degrees, but 80% of the time you will see a pi. Degrees, you will rarely see the pi, so you'll always just see the little degree sign. So that's a good way of just memorizing these things. All right, so that concludes our lesson. We're going to try 3 practice problems for beginner, intermediate, advanced level right now. Good job. All right, so we had our lesson on angle radian measurements. Let's try 3 problems. Let's try basic, intermediate, advanced. Here is your basic. So draw the angle given. There's 2 problems. A, negative 37 degrees. B, 4 pi over 3. Just negative, just a little hint. Negative degrees just means you're just going clockwise versus counterclockwise like we've been going. And then radian measurements. Think of how many 3 pi over 3 is 1 pi. How much more do I need to go or how much less do I need to go? Think of pi over 3 as thirds. We're getting perfect thirds like a slice of pizza. All right, so we have 3 perfect slices in half a circle. I need 4 of them. So that's your hint. About 30 seconds. Try your best. Here we go. All right, welcome back. Let's try this. Negative 37 degrees. We'll go that way. Y, 0, negative 90 degrees, so it's negative 37. It's in between 0 and negative 90, so we're actually in quadrant 4. 37 degrees down. So take a look at that, make sure you did that correctly. 4 pi over 3, well the way I think of it is we have 3 equal pieces to get to pi. Pi is equivalent to 3 pi over 3, 4 pi over 4, 6 pi over 4, 6 pi over 6. They're all equivalent, so I'm thinking of, we'll have 1, 2, 3. I have 3 pi over 3s, I need 4 of them, so I just go 1 more. So then this guy right here is 4 pi over 3. And we are in quadrant 3. So check your answers. We'll do more practice with radian measurements when we get to the unit circle. But start counting out. When we talk about radians, think of divided by 3, it's a fraction, so think about thirds. So we have 1, 2, 3 equal pieces. We just need 1 more to get there. All right, let's get ready for intermediate. All right, intermediate, we want you to convert from radians to degrees or degrees to radians. The 2 examples again. Example A, 45 degrees. Example B, 3 pi over 4. So the rule of thumb is if your problem is in degrees, you leave your answer in degrees. If your problem is in radians, you leave your answer in radians. But today we're just going to practice converting. About 30 seconds to a minute. Try your best. Use the formulas I gave you. Go. All right, welcome back. So 45 degrees, you're multiplying by pi over 180. So if you simplify all this, we get what? We get pi over 4. If you simplify these guys, you'll get 4 on the bottom. So you get 1 and 4. Okay, try your best. So we converted that. 3 pi over 4, we want to multiply this by, I want to get rid of the pi, so I have to put the pi on the bottom to cancel out. You put 180 on top. So those pi's cancel out. If you simplify all this, you get 135. So you can say it's like 290, 270 over 2. So you get 270 over 2. You get 135. So we converted. It's good to understand how to convert back and forth. It's also good to know how to use just radian measurements throughout. All right, check your answers, make sure you did it correctly. It's okay if you made mistakes. Our goal is to fix them. The only thing you might make a mistake here is either flipping these guys or it's just a arithmetic error. My rule of thumb is if you have radians on top, Radians will have the pi on top. You want to get rid of it, so you always put the pi on bottom. So that's how you know which one goes on top and bottom. All right, let's try advanced problem. All right, our last problem, our advanced. I want you to find one positive, and then negative coterminal. Remember, coterminal where it ends. So what do we add and subtract here? That's your hint. Here is your problem. So 11 pi over 6, and then you have negative 300 degrees. So remember, keep it as radians for A, keep it as degrees for B. And about a minute for this one. Try your best. Go. All right, welcome back. Let's try this last one. 11 pi over 6. Well, where is 11 pi over 6? Well, 12 pi over 6 is a 2 pi, so it's in the fourth quadrant. So then if I kind of sketch this real quick, here is 11 pi over 6. So then you can figure out, well, if I go backwards, what would that guy be? So negative pi over 6 is 1 coterminal. I can add 2 pi from here to get a full revolution, but 2 pi is what? 12 pi over 6? I'm just getting common denominators already. So you get what? 23 pi over 6. So that's your positive coterminal there, and there's your negative coterminal there. So I'm just adding 2 pi, but 2 pi to get common denominators, or I'm subtracting 2 pi to get get common denominators on that side as well. So negative 300, where is that at? Negative 300 that's 300. If I go the other way, that's 300 degrees there, negative. Just helps just to sketch it. So what's this guy here? That's 60, because 300 plus 60 is missing. So 60 degrees is a positive coterminal, or we could just take negative 300 and subtract 360 from it. So we get what? Negative 660 is also a coterminal for there as well. All right, so check your answers on these guys. And there's multiple, millions others, infinite amount of coterminals for these guys, because we're just going in a circle over and over and over and over again. All right, so lots of different options. All right, so that concludes our lesson for angle radian measurements. Hopefully this video helped you. Please subscribe to my channel. Please turn on notifications. And let's get ready for some more videos. Good job.